This is one of the fundamental concepts of AUX. It's so fundamental that I've been taking it for granted. Guess what? After 17 tutorial videos posted, I realized that I never clearly explained this topic yet, so here you go. Better late than never. What is the audio block? It refers to an actual audio object with begin and end time points. It is a lower-level concept than the audio signal. Say we have an audio signal of 300 Hz tone with an RMS of negative 15 dB, X, which begins at 0 and ends at 100 milliseconds. Next, we have another audio signal of 500 Hz tone with RMS of negative 15 dB, Y, which begins at 200 milliseconds and ends at 250 milliseconds. Now, for X and Y, each of these audio signals has one audio block. In general, an audio signal can have multiple audio blocks. For example, Z is the addition of X and Y. Looking at the waveform of Z, you see that there are two audio blocks that are not contiguous in time. If you wonder what's going on between 100 and 200 milliseconds, there is no defined audio signal in this interval. I'm calling it null, so it'll be phrased as null signal, null interval, or null block depending on the context. Notice that a null signal is different from a silent signal, which is actually defined with zeros. I'm making another signal Z2 from X, followed by a silent signal for 100 milliseconds, then add Y. If you compare Z with Z2, they may appear similar, and if you play them, they sound exactly the same. But the difference is there's a null block in the middle of Z, but there's silent portion in the middle of Z2. These two signals actually show different behaviors in various operations. For the RMS calculation, the null portion is excluded, but the silent portion is not. So you see the RMS of Z is negative 15 dB, the same as X and Y, but the RMS of Z2 is about negative 17 dB, lower than X and Y because of the silent interval. What do we need to know about null signals? First, for the multiplication operation, the null signal has no impact on the operand signal, but the zero signal masks the operand signal with zeros. So if you want to apply a multiplication factor to another signal for certain time intervals, but leave as is in the other intervals, using a signal with null blocks is a great way to do it. For example, say we have a sentence from hard drive and call this Z.
He picked up 9 pairs of socks for each brother.
Here I want to reduce the amplitude of waveform by half for these time portions from 550 to 1000 milliseconds and from 1600 to 2000 milliseconds. Then set up a window signal W with a constant value using the DC function. Then scale it by negative 6 dB to make it half. Then multiply them. Let's use a compound operator multiply equals so we can see the changes in Z easily. Here you go. That is what we want. Another example, I have a continuous noise that I want to chop off or gate on-off periodically. This is a bandpass noise from 500 to 3000 Hz. I want to chop off at 4 times a second. Make the window function begin with 4 Hz tone, not actual tone but just the amplitude fluctuating window function. Take only the positive intervals, then make those values 0. So that's the window function. Then multiply it. That's what we want. Second, all audio processing functions are applied per block. Therefore, if you have a signal with several time intervals you want an operation done, you should arrange it as a signal with multiple blocks. Example, the ramp function modifies the waveform near the beginning and ending points. A.ramp applies the ramping operation at all blocks, but B.ramp does only at the very beginning and very end. Another example, I'm going to adjust the duration of the audio using the timestretch function. We have two words arranged in two different ways. In one case, they are separated with a null interval. Another case, they are separated by silence.
Chain.
Love.
Chain.
Love.
In the first case, the duration is adjusted for each block, meaning that the begin point of each block is retained. In the second case, the entire duration is adjusted. Sometimes you want the first way or other times you want the second way. In the final example, you want to chop off signal periodically, but you want some smoothing effect for on-off transition to make it sound less choppy. So you want a window signal like this. How do you make it? One quick way to do it is using conditional indexing. Again, here's the target noise signal. To make the window signal, begin with 4 Hz sinusoid. Using conditional indexing, we have a half-wave rectified signal for us to use as window signal. Here we don't want null portions between periods, so add a silent signal for the entire duration. Now we have the window signal gate ready. Multiply it to noise. Job done. If you notice that this is not exactly the intended window, because that was something more so with a constant window signal with smooth transition only at the edges of each interval, that requires something a little more complicated and sophisticated. So we don't go over the details in this video. But for those brave ones, I'm showing you a hint with fast forwarded video here. I hope you got it. For most of us, it sounds pretty similar either way.